Socratic Math Tutor here. So today we're going to continue with the general project of trying to recover a function just from its graph. So once again, we'll get some axes going. We'll label the horizontal axis with X and the vertical axis with Y, just as before. And this time we'll get some asymptotes going. So here's some vertical asymptotes. And let's make it look a bit like the cotan function. Okay, and so the question is, if we know that this is a translated and dilated version of cot, how do we find the actual formula that relates y and x? So we'll begin as we did before. So we'll get some axes going. This will be called x dash, and this one will be called y dash. And we'll do our best to sketch what cot looks like. So here's some asymptotes. And it should look something like this. So it inflects actually at the x dash axis. So this is a graph of y dash equals cot of x dash. And once again, we should try and label our key features, namely these two asymptotes, as well as this inflection point here. So let's start off by finding the relationship between x dash and x. So the main thing we know is that we want x dash equals pi to map to x equals pi on 4. And we want x dash equals 2 pi to map onto x equals 7 pi on 12. And so what we can do is we can just compute this difference. Delta x dash here is pi. On the other hand, if we look over here, we find that delta x equals this number minus this number. So 7 pi over 12 minus, I'm not going to write pi on 4, I'll write 3 pi over 12. And 7 minus 3 is 4, so in the numerator we get 4. 4 over 12 simplifies to pi over 3. And so the scale factor here is clearly 1/3, and therefore we can write x equals x dash over 3 plus a constant. Now to actually find this constant, we can use the fact that x dash equals pi is supposed to map to x equals pi on 4. And so I'm going to put pi here in place of x dash. I'm going to put pi on 4 in place of x, and this gives us an equation for capital A. So when we solve, we find that a equals negative pi on 12. And therefore, our relationship between x and x dash becomes x equals x dash over 3 minus pi over 12. But unfortunately, to relate y and y dash is just a little bit trickier. And the reason is we're not really given two different useful y values, both in the domain and the codomain. I mean, case in point, like we know this needs to map to there. So the y value over here is going to map to the y value over there. So that's... Now, unfortunately, finding a relationship between y and y dash is actually a little bit more tricky than that. It's not that easy to find the dilation factor for that conversion. So here's the reason for that. We know that this point needs to map over here. So we can kind of relate this y value to this y value, which is good. But to actually get the dilation factor, we really wanted another pair of points that we can do this kind of analysis with. And the problem is, this point that we're given here, we don't really know what the y value is over here. Like, we just don't know the coordinates of the point on the left that's supposed to map to it. And the other problem is this point here has exactly the same y value as this point. So even though we can work out the coordinates of this point pretty easily, somehow it doesn't help us. And the reason is because the y value here is the same as the y value here. And so when we try and work out that dilation factor like we did in the previous video, we're actually going to wind up with 0 divided by 0, which is just not helpful. So what we'll do instead is we'll basically just resign ourselves to not knowing the scale factor. And instead of working that out as the first thing, we'll actually work out the scale factor as the last thing. Okay, so let's write y equals some kind of scale factor s times y dash plus capital B. Instead of trying to work out s, we'll start off by working out b. So we know that this point is supposed to map to this point. And over here, we have a y value of 2. Over here, we have a y dash value of 0. And so we can just put those numbers in. So 2 equals s times 0 plus b. And notice how lucky this 0 was. This 0 is actually knocking out our s here. And so we can actually find the value of b, and it turns out to be 2. So even though we didn't know s, because we were given the coordinates of a point that comes from a point in the original graph, or kind of the simpler version of the graph with y value 0, it turns out that this is enough. And so we can put in a 0 here, the scale factor drops out, and we find this constant. So y equals s y dash plus 2. So I'll get rid of our working so that we have a bit more space. There's our transformation, though it has a free parameter that we still need to find. And now what we want to do is actually solve for x dash and y dash in order so that we can plug these equations into here. So in particular, we find that x plus pi over 12 times 3 equals x dash, and that y minus 2 over s equals y dash. And therefore, because y dash equals cot of x dash, we can write y minus 2 over s equals cot of 3 times x plus 12, just like that. So this is nearly an answer. We're nearly done, but we've still got this s here. So to find this s, what we'll do is we'll take one of these points that we're given. We've already used this, so that's probably not a good candidate. I think we should use this point. And what this is telling us is that if x equals 0, then y should be 4. So 4 minus 2 over s equals cot of 3 times 0 plus pi on 12, which is pi over 4. So just rearranging a bit, we find that s equals 4 minus 2 times tan of pi over 4. This is 2, this is 1, and so s equals 2. So in conclusion, our equation becomes y minus 2 over the scale factor s we just found, which is 2, equals all of this stuff. And there you have it. So even if you can't find the scale factor directly in either the x or the y direction, it doesn't mean you should give up. Just choose letters to represent the scale factors that you're not able to find, and then in the end, by plugging in some points, you might just be able to find them.